This session will study the series fault on the power system. The series fault is also come under the unsymmetrical fault. We have got two series fault. One is called as the one conductor open fault or two conductor open fault. There are two types, one conductor open or single line open, or the another one is the two conductor open or two line open fault. An open conductor fault is in series with the line. That is these fault, they are occurring in series with the line. Whereas the sent fault, that is the take the path from the line to ground or line to line. That is a sent. Here it is, these fault are occurring in the series with the line. The line currents and series voltages between broken ends of the conductors are required to be determined. The objective of this open conductor fault is that you have to find out line current and series voltages between the broken end of the conductors. That is, for example, if there is a fault occurs at the point f dash, that is at this point there is a fault occurs, that is one conductor open fault occurs, then our aim is to find out what is the current, the line current in the open conductor, and what is the voltage profile at the fault point. That is our objective of the open conductor fault analysis. The figure which is showing here shows the currents and voltages in an open conductor fault. That is, you can see here at this particular point there is a fault occurs. Then the current which are flowing in the lines are IA, IB and IC, that is represented here. IA, IB and IC are the currents. And under the fault condition, the current are become unbalanced. Therefore, the unbalanced currents and the voltages, they are resolved into its symmetrical the components. First of all, the current and voltage in the open conductor fault, that is the line currents I am representing as IA, IB and IC. That is, I am taking per phase value here. That is IA, IB or IC are the per phase values of the current. Then VAA dash, VBB dash, VCC dash are the per phase voltages at the fault point. These are the voltages at fault point. What is that? I am considering the fault is occurring at this particular point. Then what is the voltage between AA dash, BB dash, CC dash? Means at the point of the fault, what are the voltages between AA dash, that is a fault either side of the fault, that is AA dash, BB dash, CC dash. Okay. Then if you are resolving IA into its symmetrical components, that is what I am getting is IA0, IA1 and IA2. Similarly, if I am resolving this voltages into its symmetrical components, the voltages are VAA dash 0, VAA1 dash 1, actually it is dash, VAA dash 1 and VAA dash 2. These are the symmetrical components of VAA dash, VBB dash and VCC dash. Then the point he is mentioned here, the ends of the system on the series of the fault are identified as FF dash. That is, the fault point is represented as F and the F dash. That is, the fault point is represented as F dash. Means at this particular point there is a fault occurs. Then while the conductor ends are identified as AA dash, BB dash and CC dash, that is the current, that is the voltages at the fault point on either side of the A is represented as AA dash. For the B it is represented as a BB dash, and whereas the C phase is represented as CC dash. Mean at the fault point, the either side of the fault point, these are represented as AA dash, BB dash and CC dash. The set of series current and voltage at the fault are, that is given here, the per phase currents, then it is a voltage at the fault point, then these are the symmetrical components of the current and the voltages. With this background, just we have to analyze the series fault. First, I will take one conductor open fault. The one conductor open fault. That is what I am assuming here. That is the fault is takes place on phase A. Phase A, there is a fault occurs. Fault occurs means the at fault point F, there is a conductor in the phase A. At point F, it is opened. Then my object is to find out what are the voltages and current in the event of one conductor open. Therefore, what I am doing is just once again you have to apply your basic concept of the symmetrical components. That is, I am writing here, that is the first condition, the terminal condition. Out of this, what I am getting here is the current which is flowing before the fault occurs are IA, IB and IC, because all are intact here. The currents are IB and IA, IB and IC. In the event of the fault, there is an opening of the conductor in the phase A. Therefore, then the terminal condition what I am getting here is, one is IA is equal to 0. IA is equal to 0. And the one more condition what I am getting here is, you can see what is the voltage between B and B dash, C and C dash here. As such, there is no potential difference here because they are all intact. Means they are all the zero potential between B and B dash, C and C dash. There is no potential existing because it is directly shorted here. Means there is no open conductor here. Therefore, the other condition what I am getting here is, that is VBB dash is equal to VCC dash is equal to 0. With these two terminal conditions, just you have to derive the equation for the currents and the voltages for one conductor open. Then how you have to proceed? Just you have to write the sequence, the voltages and sequence currents in terms of symmetrical components. Just first I am writing, that is VB dash, I am using the second condition, is equal to VCC dash. Just you have to express VB dash in terms of its symmetrical components of positive, negative and zero sequence in terms of the phase A. That is, we know that is standard, that is VAA dash 0 plus A square VAA dash 1 plus A VAA dash 2 is equal to VAA dash 0 plus A VAA dash AA dash 1 plus A square VAA dash 2. Just you are observing here, that is VAA dash not, VAA dash not on either side get cancelled. Then you have to look into here. You can club the AA dash on one side and AA dash to the other side. Then what I am getting here is VAA dash 1, it is A square, this term, and this term I am bringing to the left hand side, that becomes minus A here. That is equal to VAA dash 2, I will write in the right hand side. Here I have got A square, here I got A square coefficient. Then if you are bringing this to the right hand side, then what I am getting is minus A VA dash, therefore I am putting here minus A. Then ultimately what I am getting is, the one condition from here is that VAA dash 1 is equal to VAA dash 2. This is one condition what I am getting here. Then you have to look into the other condition. The value of VBB dash, you can put the the condition here on in any one of the equation. That is from the VBB, what I am getting is VAA dash 0 plus A square VAA dash 1 plus A VAA dash 2 must be is equal to 0. I am using this condition, that is VBB dash is equal to 0. However, VBB dash I am expressing in terms of the symmetrical components. Then one more condition I know, that is VAA dash is equal to VAA dash 2. Therefore, what I am putting here is, it is VAA dash 0 A square VAA dash 1. Then this I am putting as VAA dash 1, because both AA dash 1 and AA dash 2 are equal. Therefore, the what I am getting here, that is VAA dash 0 VAA dash 0 plus A square plus A into VAA dash 1 is equal to 0. Whereas this value is minus 1. If you are transferring to other side, then what I am getting here is VAA dash is equal to VAA dash 1. Also we are derived, that is it is also is equal to VAA dash, means ultimately all they are equal, that is AA dash 0. This is important conditions we are getting from the voltage. In the same fashion, we have to go ahead with for the current relation. The same thing I am showing here, already it is prepared here, just I am explaining this concept here. That is first condition what I told you, that is VBB dash and VEC dash is 0. And second terminal condition is IA is equal to 0. Therefore, if you are expressing in terms of symmetrical components, then what I derived here is VAA dash 0, VAA dash 1, VAA dash 0 are all equal. Therefore, I am putting here VAA dash 1, VAA dash 2 is equal to VAA dash, that is equal to 1 by 3 VAA dash. That is, we know that if you are putting in the terms of VA, that is VA is equal to, it is VAA dash 1 plus VAA dash 2 plus VAA dash naught. All are equal, all the things are expressing in terms of the any one of the parameter, that is VA is equal to, that is VA is equal to, it is called 3 times VAA dash 1, or VAA dash 1 is equal to VA by 3, that is equal to VAA dash 2, that is equal to VAA dash 0. The same thing I am written here. The same thing I am written here. Just you have to go by the basics and you have to substitute the value. Therefore, from the condition of 1, that is from the first condition, I derived all the voltages, sequence voltages are equal, that is equal to 1 by 3 times VA dash. At the same time, we know that the broken conductor is on phase A, therefore IA1 plus IA2 plus IA naught is equal to 0. Therefore, equation number 3 and 4, that suggests the parallel connection of the sequence network as shown in figure. That is, if you look into there, all the voltages are equal. All the voltages are equal means positive sequence network, negative sequence network and zero sequence network voltages are, terminal voltage are the same. Therefore, they are connected in the series. And the sum of all these IA1, IA2 and IA0 is equal to 0. That is demonstrated here. Here you have got a positive sequence network, negative sequence network and zero sequence network. Then you can see here all they are connected in parallel, that is at the point of F, all the F points are shorted. This is the parallel connection. It is a one side is commonly connected. The second one is connected here. that is all these are connected in parallel. Means the A dash 1, VAA dash 2 and VAA dash naught, they are all connected in parallel. They are all connected in the parallel. Therefore, at the same time, you look into the second condition, that is the fourth equation, IA1 plus IA2 plus IA0 is equal to 0. You can see here, all the currents are the merging here, that is they are all incoming current here, IA1, IA2 and IA0. But as such, there is no the output current from here. There is no outgoing current here. Therefore, the sum of IA1, IA2 and IA0 is equal to 0. That is quite evident from this circuit connection. Means when the one conductor is open, the condition prevailing at the terminals are VBB dash and VCC dash is equal to 0, IA0 is equal to 0. This is the boundary condition. From this boundary conditions, what we are getting is the current IA is becomes 0 and all the sequence voltages, that is VAA dash 1, VAA dash 2 and VAA dash 0 are all equal to 1 by 3 VAA dash, so that the sequence networks are connected in parallel. This is how to analyze one conductor open fault. Then we will analyze here the two conductor open. I will consider here the fault is occurring at once again at the point FF dash. Here the fault is occurring in the two phases, that is B and C. I will consider B and C. If the conductor is open at point B at F of in the phase B and C, then the prevailing conditions, what are the conditions there? You are getting here. That is the first condition. What we are getting is VAA dash is equal to 0 because this point is intact. This point it is intact. Therefore, VAA dash is equal to 0. Then there is a broken conductors in phase B and C. Therefore, your IB and IC both are equal to 0. You have to make use of these two conditions, and once again you have to substitute in the sequence voltage and the currents, and you are getting the terminal, you are getting the relations for positive, negative and zero sequence current and voltages here. The same thing I am doing here. The first condition VAA dash is equal to 0. The another one is IB is equal to IC is equal to 0. Then I know that is the first condition VAA dash is equal to 0. How we are writing a VAA dash? How we are writing a VAA dash? VAA dash is equal to VAA dash 1 plus VAA dash 2 plus VAA dash not. That is I am writing in terms of sequence current. That is here the voltage is 0. Therefore, I am putting this as 0. The same thing I am writing here. That is the sum of VAA dash 2 plus VAA dash not is equal to 0. That is one condition. That is I am deriving from this. Just I am putting VAA dash in terms of its symmetrical components. The second condition is IB is equal to IC is equal to 0. IB is equal to IC is equal to 0. Just you have to make use of sequence current equations. That is, I will write here for IB and IC. You are appreciating that. That is IB. What I am writing here is A square IA1. That is, I will call AA dash 1 plus AA dash 2 plus AA dash not. Okay, just I will make this correction. That is IA dash 1. Okay, then IC is equal to, it is AA dash 1, here A square IAA dash 2 plus it is IAA dash not. Then both are equal to 0. Just you have to equate. You have to equate IB is equal to IC. Then what you are getting here is the conditions. Once again we are getting I just like a voltage. In this case you are getting IA1 is equal to IAA dash 1 is equal to IAA dash 2 is equal to IAA dash naught is equal to 1 by 3 I, 1 by 3 I. This is the conditions what we are getting, that the same thing I am writing here. Okay, just you have to look into this. Okay. Okay, that is making use of this VA dash is equal to 0 and making use of IB is equal to IC. Put the value of IB and IC in a symmetrical components, then what I am getting is this value. That is IA1 is equal to IA2 and IA0 is equal to 1 by 3 I. Then if you look into observing into the current equation, all the sequence currents are equal. Means if the current in the different networks are same, means all those networks are connected in series. Therefore, this is suggesting that the positive sequence, negative sequence and zero sequence networks, they are connected in series. The same thing I am doing here, that is from F dash you can look into here. It is connected to the F, that is the end of the first is connected start of the third and end of the third is connected to start of the second and end of the second is connected to start of the first. Means it is all positive. There, as such, there is no overlapping here. It is no overlapping here. Therefore, the positive sequence, negative sequence and zero sequence networks, they are connected in series. You can look into the current direction also. Very carefully you can observe here. The current IA1 is from the positive sequence, IA2 is from the negative sequence, IA0 in the zero sequence. What is the path here? See here, current is flowing here, it is entering here and it is coming out of this and it is once again entering here and come out, and once again the current here is, that is in a whole it is a series circuit. The current is IA1, that is also equal to IA2, that is equal to IA0. All the currents are equal. Therefore, the sequence networks, they are connected in the series in the case of two conductor open series fault. This is how we have to analyze the series fault.